BSc Part 3 Nuclear Physics. Today we will be discussing binding energy of a nucleus. Before proceeding, we must note what are atomic numbers, mass numbers and number of nucleus of a nucleus. For 92 uranium-238, the atomic number is 92, mass number is 238 and number of neutron is mass number minus atomic number. So the binding energy is defined as it is the energy which is required for separating the constituent particle of the nucleus. We know that the constituent particles of a nucleus is nucleons, which means proton and neutrons. So if we supplied an amount of energy to the nucleus to separate these nucleons from the nucleus, then this amount of energy is called binding energy. In the same way, if we bring them proton and neutrons from infinity to form the same nucleus, then the energy required to form that nucleus is also called binding energy. So the binding energy is required to bound the nucleus to bound the nucleons. If mH is mass of a hydrogen atom and mAz is mass of that atom whose binding energy is Eb, then binding energy can be written as ZmH plus A minus Zmn minus MaZ C square. Here Z is the number of protons and mH is mass of proton, which is equal to mass of hydrogen atom, and A minus Z represents the number of neutrons and Mn is mass of neutrons, and MaZ is the mass of that atom, which is whose binding energy is Eb. Now we will show what is mass defect. This is defined as the exact mass MaZ of a nucleus of atomic number Z and mass number A is less than the amount of its constituent nucleons. Then the difference is called mass defect. So this is the mass of its constituent particles and this is mass of a nucleus, and the difference of these two is called mass defect. Here notations are same as in the previous topic. Some energy equivalent to this mass defect will have to be given to the nucleus to separate all nucleons from each other and send them to infinity. This energy is called binding energy of the nucleus, which means if we provide the energy equivalent to mass defect delta M, then this energy can separate the nucleons and can send these nucleons to infinity. So mass defect is somewhat equivalent to the binding energy, and from mass defect we can calculate the binding energy by using this formula. So if we calculate the delta M of any reaction, multiply it by 931.5 mega electron volt, we can calculate the binding energy directly. Now packing fraction. Packing fraction is defined as the difference of exact mass m of the atom and its mass number A. per unit mass A is called packing fraction of that atom. So packing fraction is m minus a upon a, and delta is mass excess. By definition, we take packing fraction 0 for carbon atom. F can be positive and F can be negative. For elements which have mass number less than 20 and greater than 180 have their packing fractions positive, and the elements which lies between mass number 20 and 180 have their packing fractions negative. If packing fraction is negative, then it shows that the nucleus is somewhat stable, which means some mass has been converted into energy during the formation of a nucleus. And if we provide some same amount of energy, then that nucleus can be separated